Okay, so today we'll be doing long divisions of polynomials. So we're first going to start out by doing a problem with integers, just to remember what long division is like. So here we have our problem 78 divided by 7. Now the way we set it up is the divisor, which is 7, it's going to go on the outside of the radical. 78, which is the dividend, will go inside the radical. So that's how we're going to set it up. Now, to begin long division, you have to ask, what times 7 will give us 7? And the answer to that is 1. So then we multiply 1 times 7, which gives us 7. So we put a 7 down there. However, part of the rule of long division is you have to change the sign. So because this is a positive times a positive, that'll give us a positive. But we have to switch the sign, which will then give us a negative. So that means that you're going to do 7 minus 7, which is 0. Next, you're going to bring down the 8. And then you're going to ask yourself, what times 7 will give us 8? Well, the answer to that again is 1. So we're going to put a 1 up on the quotient bar, right up here. Now 7 times 1 is positive 7. However, again, rules of long division, you have to switch the sign. And this changes to negative 7. So we have 8 minus 7, and that gives us a remainder of 1. Now you may be asking, well, what do we do with the remainder? What does that tell us about the answer? So we know this to be true, that 78 will equal 7 times 11 plus 1, because we know that 7 times 11, which is the divisor and the quotient, those two multiplied will give us 78. However, because we have this remainder, we have to account for that. So we have 7 times 11 plus 1. But to find the answer, we're going to divide each of these integers by 7, including this one. And this will give us 78 over 7 equals 11 plus 1/7, which 11 plus 1/7 is our answer. That's the quotient that we were looking for. So now to find long division with polynomials. So the question asks, use long division to find the quotient when f of x is divided by the divisor h of x. So here we have f of x equals x squared minus 6x minus 27, and our h of x is x plus 3. So again, we're going to set it up with the divisor on the outside, which is x plus 3, and the dividend on the inside, which is x squared minus 6x minus 27. So we're going to first begin. You take this x, you ask yourself, what times x will give us x squared? Well, that's easy. That's just x. So an x will go up here. Now, just like with other long division with integers, you're going to multiply it out. So x times x is x squared. And again, positive times positive will give us a positive. So that's why the sign right there is positive. And then we're going to do 3 times x is 3x. Again, positive. But again, remember rules of long division state that you need to change the sign. So both of these are going to switch to negative. Okay. So now we have x squared minus x squared and negative 6 minus 3x. So we're going to do that out, and that'll give us negative 9x. These two cancel and give us 0. Now, again, with the rules of long division, you're going to bring down this number. So we have negative 9x minus 27. Now, again, we're going to take our x and ask ourselves, what times x will give us negative 9x, which is negative 9. So that's why I put a negative 9 up here where the quotient is. So now we have a negative 9 up here, and we're going to multiply that by x like we did when we first found these. Now, negative 9 times x will give us negative 9x. And 3 times negative 9 will give us negative 27. Now, remember, we need to change the signs. So these two will both change to positive. So now we're going to do this problem out. So we have negative 9x plus 9x, which will give us 0, and negative 27 plus 27, which will give us 0. So therefore, we have a remainder of 0. Now, what does this tell us? It tells us that x squared minus 6x minus 27 equals x minus 9 times x plus 3. So we know that h of x is a direct factor of x squared minus 6x minus 27. All right, now number 3. The question again is use long division to find the quotient when f of x is divided by the divisor h of x. So we have here f of x equals 4x to the 4th minus 3x squared plus 3x minus 2, and our h of x is 2x minus 1. So again, we're going to set it up with the divisor on the outside, 2x minus 1, and the dividend on the inside, 4x to the 4th minus 3x squared plus 3x minus 2. Now you may notice we have this big gap right here. Well, what is that? Now, when we're doing long division with polynomials, you have to account for coefficients and variables that may be missing in a sequence. So we have to account for this x to the third. So here we added 0 x to the third. And this helps keep more organized, and that way you can actually do out the addition, which I'll explain what that really means in 1 minute when we come to it. But you can see I just added in a 0 x to the third. So we're going to start our problem. So we ask ourselves, what times 2 of x will give us 4x to the fourth? Well, that is 2x to the third. So again, now we take 2x times 2x to the third and multiply it, which will give us 4x to the fourth. And again, positive times positive is a positive. And then we take 2x to the third times -1, which will then give us -2x to the third. Now you see why adding in the 0x to the third came in handy, because if we didn't have that in, then we wouldn't really know what to subtract this from. So having that 0 in helps keep us accountable to make sure that we're using this properly. Now again, the rules of long division, we have to change these signs. So this will become -4x to the fourth plus 2x cubed. Now, because these two cancel out, and 0x to the third plus 2x to the third is 2x to the third, we're then going to bring this number down just like we do in regular division. So now we're going to ask ourselves, what times 2 of x equals 2x to the third? Well, that is x squared plus x squared. So here we have x squared times 2x, which is 2x to the third, and x squared times -1, which is -x squared. So again, you see we have our signs here, but those are going to change. Because again, rules of long division state you have to change the signs. So this becomes 2x to the third minus 2x to the third minus 3x squared plus x squared. So it moved a little bit, but here you can see these two cancel out, and that'll give us 0. -3x squared plus x squared will give us -2x squared, and then we bring down the 3x. Now, what times 2x is -x squared? Well, -x, that's where this came from. So we multiply -x times 2x, which will give us -2x squared. And then So again, we multiply 2x times -x, which will give us -2x squared. And then we have -1 times -x, which will give us plus x, which the rules of long division, which you guys saw when I skipped the slide, you change the sign, and this becomes plus 2x minus 2x squared minus x, which will give us 2x. We bring down the -2. Now this is going to be our last step, basically. So we have 2x times what will give us 2x? Well, that's plus 1. That's where this came from. Now we take 1 times 2x, which will give us positive 2x, and 1 times -1, which will give us -1. Now again, rules of long division, you have to change the sign. This becomes 2x minus 2x, and then minus 2 plus 1, and this gives us a remainder of -1. Well, what does this tell us about the answer? It says that the divisor h of x, which is 2x minus 1 right here, is not a direct factor of this dividend. So you can't really write out this quotient and then multiply by that. But then if you wanted to, you could, and you could say that this times this, and then you would have to find the exact remainder. But yeah, so this tells us that this is our quotient. This is basically how you would do long division. So we're going to move on to our last problem. Number 4, again, use long division to find the quotient when f of x is divided by the divisor h of x. So we have here that f of x equals x to the fourth plus x squared minus 1, and our h of x is x squared plus x plus 1. So we're going to start out by writing our equation. Again, I've added in 0x to the third, but this time we're also missing an x. So normally it would be 4, 3, 2, 1. Think of x to the first being the same as x, and minus 1. So we have to add these two in. So when I wrote out the problem this time, I put, again, the divisor h of x on the outside, x squared plus x plus 1, and then the dividend on the inside, including these two. So we have x to the fourth plus 0x third plus x squared plus 0x minus 1. And again, we add these in because it helps keep us accountable when we're subtracting. So that, say we have to, say x squared times x will then give us x to the third. Say we have to subtract that, but there is no x to the third variable in there, then we may make a mistake. So this helps keep us accountable. So we're going to ask ourselves, what times x squared will give us x fourth? So x squared times what will give us x to the fourth? The answer to that is x squared. So again, we're going to then multiply this number, or this variable, excuse me, by each of these. So then we'll have x to the fourth, positive x to the fourth, positive x to the third, x squared times x is x to the third, and then x squared times positive 1 is positive x squared. So again, rules of long division, you have to change all the signs. And that will give us that. So then you're going to just subtract, and then these will cancel out. And then we will have negative x to the third plus 0x squared plus 0x. So x squared minus x squared will give us 0x squared. Now, again, I included it. I didn't really need to include that because we won't be using this function again, but we will be using x squared again. So I'm going to then bring down the 0x like you normally would. And then you're going to ask yourself, what times x squared will give us negative x cubed? The answer to that is negative x. So then multiply negative x by each of these variables, and we get negative x cubed minus x squared minus x. So that's pretty self-explanatory, but again, got to change the signs. And yeah, that'll give us that. So these cancel out. 0x squared plus x squared will give us x squared. 0x plus x equals plus x. And then we bring down the negative 1. Now this was here a little bit premature, but I'll explain what that is in a second. So x squared times what will give us x squared? Well, that's easy. That's positive 1. So you're going to multiply positive 1 by each of these. So positive 1 times x squared is x squared. Positive 1 times x is x, and positive 1 times positive 1 is positive 1. Then you're going to change the signs, and these will cancel, so will these, and negative 1 minus 1 will give us negative 2. So what does this tell us about the problem? Well, we know that it is not a direct divisor, that the divisor h of x is not a direct divisor of the dividend. So we're not going to write it out for now, but we know that this quotient times this with then some remainder involving 2 will then give us the dividend. Yeah, so then here's me. I'm Jillian Chanko. I'm graduating in the year 2017. I'll be heading off to Oberlin College and Conservatory in the fall, where I hope to major in anthropology, as well as some philosophy. So yeah, these are just some things that I like and things about me. There's a little Birkenstock, and there's my little puppy Ellie. So yeah, I hope this helped. I hope you enjoy math, and yeah, thank you for watching.